Hey, good Friday, everybody. Brian Bledsoe with you here, host of the Desert Farmer Podcast. Thanks so much for joining me again. It has been an incredibly busy past couple of weeks for me, traveling across the Western High Plains. I've been in Sydney, Nebraska, Wichita, Liberal, Sublette, as far northeast as Aberdeen. And we're going to continue to be very busy the remainder of this month, traveling across the Western High Plains. So I know a lot of you listen to this program. It was absolutely fantastic to be able to sit down, have some meals with you guys, a couple of drinks, and really, get to talk with you for an extended period of time. I greatly appreciate your loyal listenership here, and it was just fantastic to get out on the road and see a lot of you. I've got a lot of stuff to share with you today, and I'm really excited about it. It is the early part of the month, which means that the seasonal forecast information comes in, whether it's the Canadian seasonal model or the Euro seasonal model or the NMME, or as we head toward the middle part of the month, the IRI multi-model probability. Anyway, I love to go through this stuff, not because I think that these models are the end all be all when it comes to long range forecasting, but we can always glean some things from them that help us out when we go forward with this seasonal forecast. So that's what I've been sharing with a lot of folks across all the Great Plains, and that's exactly what I'm going to continue to do going forward over the next several weeks when we've got some seed meetings, some grower meetings. It's just a really fun time for me. What we're going to start out with first today is looking at the oceans. This is where we always like to start because there have been some significant changes take place with the oceans over the past few months or so. And this is where we sit right now with the current sea surface temperature anomaly. And I've got these four different areas highlighted. We have warming continuing over here in the Indian Ocean after the Indian Ocean dipole had been in a negative state for a considerable amount of time. We have still the La Nina episode, or what's left of it, just kind of, kicking along here that's trying to hang on, but it's just not having a whole lot of luck. We've got the North Pacific, most of it is warmer than average right now. And then the North Atlantic right here, this little pocket extends continue to be cold. Now, just looking at this map, there are a few things that really jump out at me. First of all, this La Nina is dying, and it has been dying. And I'm going to talk more about that and why it's continuing to really die here in just a second. But we've had warming start to take place here across the western part of South America. We've had a lot of warmer than average water pooled up all across the west and the southwest Pacific. This has been pooled up here now for the past couple of years. And this is really important to me here. All right. Especially this area off the west coast of North America, off the Baja. That area continues to be warm. This little area that extends from the Baja out here to the southwest, that's a very positive look at the Pacific meridional mode. So it's in a very positive state. And historically speaking, when we have kind of this little pocket of the North Atlantic cooler than average, kind of coinciding with the La Nina that's going on, a lot of times the west and southwest part of the country ends up being drier than average, and that kind of spills out into the west and southwest high plains. And that's kind of what we've been seeing off and on over the past few months or so. So a lot of things going on right here. If we look at how things have changed over the past 7 days, we've had further warming going on in this sector here. And we've had quite a bit of warming that's starting to unfold here off the west coast of South America and also down here farther to the south. And then the Indian Ocean is still continuing to warm up. So overall, we are starting to warm that equatorial part of the Pacific Ocean as we put this La Nina to bed and we look forward to what is next. Now, we still have some easterly trade winds that are going on here. This is a trade wind forecast starting tomorrow, February 7th, going through the 21st. I showed this graphic to you folks a lot because when we're dealing with La Nina or a transition toward El Nino, it really says a lot by looking at what the trade winds are doing. So all of this blue that you see right in here continues to be easterly trade winds. All right. So you might look at that and say, man, this is going to continue to maintain this La Nina and maybe strengthen it. All right. Not so fast on that. And then farther west, we've got a couple of different westerly wind bursts that are trying to set up. But because these easterlies are there, that westerly wind burst can't just race across the Pacific that way. All right. So while we have those easterlies in place, let's see what's going on beneath the surface because this is really important. Over here on the upper left, think of that as like Indonesia. And over here on the upper right, think of that as South America. Look at all the cooler than average water that was there from late November through December. And look at what it's doing right now. All of that warm water that's been pooling up in the West and Southwest Pacific is actually continuing to undercut any of those cool anomalies. So think of it this way: if we have easterly trade winds blowing like this, that would normally upwell cooler water from beneath and keep that La Nina episode going. But you know what? You can clearly see that there's no cooler than average water beneath the surface. It is all warmer than average water, and in some cases, a lot warmer than average. And really, this continues to reiterate the handoff here from killing La Nina, going to neutral, and paving the way for a transition toward El Nino. And I've been yapping about this now for quite some time, and this continues. This map in particular really continues to reinforce those thoughts that I've had previously, that I've shared with a lot of you previously. So if we look at the Nino 3.4 index right now, we're still down to a negative, 0.88. But we maxed out there in late November. We maxed out here in late December. And since then, we've continued to weaken it. And then here recently, just kind of flat. So you can see, even with those easterly trade winds, it hasn't strengthened. It's just basically remained. And as we continue to see that cold pool erode, and we start to, change the narrative here of the ocean and the atmosphere, this Nino 3.4 index is only going to become more positive in time, in my opinion. The latest European seasonal model, and I shared a lot of this with you on Twitter yesterday. If you don't know my Twitter handle, it's just at Brian Bledsoe. You can go check it out. And I talk about a lot about this stuff. But if we look at the sea surface temperature anomaly plume forecast here, there's a couple of things that are really interesting to me. Let's just lop this first part off into May. All right. Look at how closely clustered all of those individual members are here. That's what all those red lines are. That to me is the model having very high confidence in what this transition is going to look like. So even if it wasn't as high end as this one up here or as low end as this one down here, just take the average of where this is going to end up in May, and we're probably going to be right there around positive 1 degree Celsius. All right. 1 degree C above average there. Right now, we're down here at a half degree C below average. Or if you look at the Nino 3.4 index that I showed you, negative 0.88. All right. So we are going to make about a degree and a half to a degree and 3/4 change here from the cool to the warmer side of things between now and May. That is a rapid transition. And if we get beyond May, if you look up here, some of these on members have us up there a little bit above 2 degrees Celsius above average, but even the lower echelon here still has us down here around positive 0.5 degree. If you take the mean of that, you end up at about a degree, 1.3 degrees or so above average, just by taking the mean. And one of the things that this model indicated to me yesterday, and I've talked a lot about this with you individually, but that there is potential for somewhat of a higher end event with this, that it may not be just sitting down here around something that's a weak El Nino. There is potential here for a moderate El Nino and possibly even a strong one, depending on how things go. Now, that is quite a ways out there. And I don't want to put the cart before the horse here. We have to do some things before that is achievable or even on the table. But some of these members with the European seasonal are indicating that right now. But I'm much more focused on the higher confidence forecast down here, and then we'll worry more about what happens out here. Either way you cut it, we are headed toward El Nino. That type of thinking is just undeniable right now, even if we're just taking the European model or not looking at any other models at all. If we put that graphic on a map here, you can see what the transition is like. So remember those different parts of the ocean that I highlighted. Most importantly, we've obviously eliminated any cold pool as we go forward from February through August, and you can clearly see the El Nino going right there. And then up here across the North and the Northeast Pacific, do you see all the warmth here? Or at least warmer than average temperatures here off the west coast of North America, down off the Baja, even up here in the Gulf of Alaska. So when we look at this, historically speaking, at least in the high desert and across the Central Plains, I'm talking about that area in particular, the Great Plains, from north to south, we usually do not have to worry about drought when we have this configuration going on with the warmer than average sea surface temperatures here from the Gulf of Alaska off the west coast of North America, as well as this El Nino going on down here for the majority of the area. Okay. Now there can be pockets of dryness, and I'm going to talk more about that. But or there can be dryness on the front and wetness on the end, or vice versa, depending on where you're located. Bottom line, I really want to drive the point home that every El Nino and every La Nina are different. They each have their own nuances, but when you can put a bunch of different subset years together to get an average, you can definitely find some pattern to chaos. Now, I've talked some about could this El Nino, all right, bring about a positive pop toward the PDO. Well, here's the PDO values since last January, and we are very close to where we were last year. All right, last January we were basically just a little less, okay, or a little more than negative one. Same story here. We were right there at about negative one. So very similar spots. Last summer, you saw what happened here. We bottomed out here in July down at about a negative 3.3. Now, that wasn't all in a traditional negative PDO state. And by that, I'm saying back last year, we had really warm water here and just less warm water here. The whole North Pacific was warm. All right. So it's not that typical. A lot of cases, a lot of times you will get a cool ring here. All right. That this area would end up being cooler than average. And then this area was warm. We didn't have that last year. It was just in relative terms, it was a lot warmer west and just not as warm farther east. So that's one of the reasons why we bottomed out down here. But because we kept those sea surface temperatures warm, relatively speaking, right there off the west coast of North America, we didn't have to worry about moisture in the middle part of the country. All right. In fact, in some cases, it was the exact opposite. We had to deal with too much water at times. So it kind of changes how you think about this positive and negative PDO thing. That even though we had a stout negative PDO last summer, that it really wasn't the traditional way you would think of a negative PDO. All right. You see what I'm saying? I think that's an important thing to recognize going forward if we continue to keep the North Pacific, especially the West and the Northwest Pacific, so warm relative to the eastern side. So some key ENSO points here, and then we'll move on. The El Nino development continues to appear likely in the coming months. That just seems like a done deal to me. There is potential for quick development, all of what we had in 2023. I'll elaborate more on that just a little bit. The strength of the event will remain in question, but there's potential for a higher end event. Okay. We have to at least recognize that fact. The Northeast Pacific continues to look warmer than average this warm season. Could that lead to a pop in the PDO? Maybe not even going all the way positive, but at least keeping us around neutral. I think that is something that is realistic because this El Nino that's coming up, with the way it looks right now, all right, looks to be maybe more along the lines of a more traditional El Nino that can provide a pop in the PDO, much like what we had back in 2015 or much like what we had back in 1997. I'm not saying we can get as strong as that necessarily because those were high-end events, but this was looks to be more of a traditional event, which could possibly lead to that. I am really excited to see how this plays out because we are coming to the end of that 20 to 30 year cycle of the PDO. This is year 27 of a negative PDO in the Pacific Ocean right there. So hopefully this El Nino would be strong enough to maybe where we could give it a pop. Well, it's something interesting. It's something to look forward to. See what happens here. All right, let's dive into the seasonal model info. Let's look at the temperature stuff first. February through August. This is the temperature forecast it had for February. Now, the first 2 weeks of this month are basically going to be a blowtorch here all across the middle part of the country. So it would take a really significant change in the pattern to cool this off. I don't think that that's going to happen. I think with this flow coming in off the Pacific Ocean, that we're just going to continue to flood the middle part of the country with Pacific-oriented air that's going to keep us warmer than average. Now, we go to March, and in March here, you see those warm anomalies weaken a little bit, especially up here to the north. and they're more centered farther south and southeast. That could mean some cool shots coming in like this. All right. I have to wait and see. But if we go to April, you kind of see more of that. All right. These models, whether it's the European or the NMME or the Canadian, a lot of times are not good at seeing cold air or cold shots. So you kind of have to read between the lines of what the model is suggesting. And what I see here, if you have all this as average in white, just average temperatures, I wouldn't be surprised to see some of those cool shots come in like this because the main core of the warmth, all right, is centered back here to the west and southwest. So we could get some late season cooler air come down like that. We'll have to wait and see. May, same story. There is no significant heat signal here on the Euro seasonal in the middle part of the country. It's situated back here to the west. Okay. A little bit here across southern Oklahoma and down into Texas, but certainly nothing up here to the north that would indicate some excessive heat, at least early on. All right. June, same story. Look at that. I think that there's a better shot that this area here that I just kind of highlighted ends up being cooler than average versus warmer than average. I think the better prospects for heat are farther west and northwest. July, even if this light yellow verifies, if you look down here at the scale, it's not high end heat. It's just skewed a little bit. But if we're putting a lot of water in the ground in the midsection, the prospects of us going off hotter are greatly reduced because that wetter soil heats up a lot less quickly every day and to a less magnitude. All right. August, same story. All right. Any significant heat signal is positioned a lot farther south down here. This is very typical when we develop an El Nino to get heat down here across parts of Arizona, New Mexico, Texas, farther north. It's far less of a problem. And then if we go and look at the precipitation anomaly forecast, again, February through August, this is what you get for February. Again, still potential dryness here. I think this is very much what's going to pan out here in this brown as we have lingering La Nina impacts, all right, where we don't have and haven't had much of a subtropical jet yet. And then you're wetter up here farther north, especially during the middle and latter part of this month, all right. March, you can see where the action is right through these sectors here, all right, which indicates to me that there's still going to be some potential dryness here across parts of the western high plains, especially the farther south and southwest you go. And then as these storm systems kick out like this, they hit the moisture from the Gulf of America and they light things up here the farther east you go. That to me would be a typical March pattern with the way things are set up. Because remember, we're not in El Nino in March. We are still doing the transition. All right. Still not there, just beginning it. April, I still think that it's possible that we have some dryness scattered back through these sectors. Now, right now, east and southeast Wyoming, western Nebraska, far northeast Colorado, and the northwest corner of Kansas are a lot drier than average. All right. Specifically up around Sydney, when I was up there this last week, had a lot of folks saying that since November 1, they've had like 4/100ths of an inch of liquid. Been a very dry winter in that area. And that has helped carve out, some droughtiness here. Now, can we fix that? Sure, but we need to do that. And a dry March and a dry April would only make that situation worse. And you can kind of see the alley where the better moisture is going here from a good part of Texas, eastern, southeast Oklahoma, and on into the upper Midwest, and also across parts of the northern tier here. May, here we go. We start to see dryness develop farther northwest. Some of that may still linger here across parts of the western high plains. We're wetter than average through these sectors here. All right, right through there. That's what the model is suggesting for May. And I'll give you the history about what I think has potential for May here in just a little bit. If you have listened to this program before, you know what I'm going to talk about. But for July or June, I should say, all right, in June, We've got wetter than average conditions here across parts of the northern plains, the northern Rockies, central plains. I'm not really sure what this is about here in southern Kansas and north central Oklahoma. All right. But if we're wet here and we are wet here, chances are this region is going to be wet. All right. Through June. July, it gets even wetter for a lot of areas here. Middle part of the country, north, really this whole area. All right. And we could even bring it back here to the Corn Belt. This whole area turns off wetter than average, big time. August, same story. One thing that I'm interested in August here, notice the dryness here in the Southwest relative to the monsoon. Um, that's something that we're going to have to watch to see if that's something that's going to continue to show up in the modeling. All right, if the monsoon's going to be cut. But areas out here in the middle part of the country, at least for the heart of summer, look a lot warmer than average. Now, if you live in Texas, at least the eastern half of Texas, I would say your better moisture prospects probably arrive for the spring and early summer. And then through the heart of summer, July and August, you dry out a bit. Okay. And some of that dryness could be significant in places, as I'll show you in a second. But right here in the midsection, I mean, if you just a little bit of dryness up front, followed by a lot of rain thereafter, and no huge heat signal, that even if you had to skate through some dry time, all right, but you got a little bit of rain here and there, but you skate through the dry time, the fact that you wouldn't have a huge amount of heat to go along with that dryness can help you go a long way. In 2018, we saw that in the Corn Belt, and in 2023, we saw that in the Corn Belt, that we were dry, 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 and then we hit to August, late July and August, the rains came, saved everything, really, but it was really the fact that we never had any giant heat in the Corn Belt to go along with that dryness that enabled things to save it. All right. A lot of times it's that heat that becomes a real problem in conjunction with that dryness. But that's what it looks like right now. So let's look at the potential temperature and precipitation anomaly analogs for March through September of this year. Most of these are similar. I've added another one here. So what I'm going to do with you, I want to show you what we're looking at in terms of La Nina and El Ninos here with the months here. So over here, you see December, January, February, got the year here. And 1951 is one of my analogs. Why? Well, because we started out in 1951 with that weak La Nina, and then we transitioned here. Look at that, June, July, August, we were already there at 0.5 degrees C, okay? Way up there. All the way over here to 1. So we started La Nina, went to El Nino. 1957, that's another one. So I'm just going to underline my years here. 57. Started off, I would say, with a weak La Nina activity. And by March, April, May, look at that. We were already, technically meeting El Nino criteria, and we continued to warm it thereafter. Pretty good El Nino event, 1957, right through early 1958. And if you're familiar with Great Plains drought history, you know that 54 through 56 was a mess. In many cases, some of those dry anomalies that occurred during that 3-year stretch right there were worse than the 1930s, depending on your location. So we came out of that triple La Nina to a pretty strong El Nino event right there when we got into 1957. And I can remember my grandma telling me that those years, the dirt blew and it flipped like a switch. It stopped. We got a ton of snow. We had active severe weather. You go back and look at some of the tornado statistics in 1957. Imagine to yourself what it would have been like had everybody had an iPhone to document all the tornadoes that went on in 1957. That's some interesting history right there if you're into that kind of thing. Also, 1965. 1965, we started with weak La Nina, and then we went to a pretty decent El Nino event. By May, June, July, we were already at 0.7 on the warm side here. So those 3 years are on the table. Out of all those 3 years, what am I favoring? I'm favoring a quicker transition in my gut. That's what this tells me based on the evidence that I see right now and where we're going. So the more delayed that the historical events are, those might be a little bit more on the outline part of this. But those are three of them right there. What about the 70s? How about 1972? We started there, not technically meeting weak La Nina, but you're real, real close. And then by April, May, June, we already popped to 0.5 and we continued. Look at that. Pretty strong El Nino event right there, up there in the twos. All right. What about the 90s? 97. There we were at right there at the La Nina threshold. And then by April, May, June, we were already at positive zero point 0.7. And then we went on to have one of the strongest El Nino events on record that year. Again, I'm not talking about, the strength of this upcoming El Nino event. I think that that's a little bit in question. But as I showed you what the Euro seasonal model was doing, there is potential for a little bit more of a higher end event with this. But that's the 90s, 2000s, maybe '02 in there, but technically we weren't in La Nina at that time. So I'm leaving '02 kind of alone, even though we went to El Nino, by May, June, July. I'm more interested here in maybe '09, where we were in La Nina, December, January, February. We went completely neutral, April, May, June. And then by July, August, September, we were there. Again, I think that that's a little bit late with what this event is going to do. And then if we look over here beyond that, 2018, same story. We were technically still in La Nina in that March, April, May timeframe. And then we didn't technically hit El Nino until September, October, November. We still had the transition there. I just think that this transition is going to happen more quickly. I think much more akin to what happened in 23, where we were negative 0.8 December, January, February. Right now, we're at negative 0.5. Okay. But we were negative 0.8 there. And then by May, June, July, we were right there in El Nino territory and went on to have a pretty strong event. I do think that El Nino event in 23 was a little bit of a different animal, if you will. Maybe not as traditional as what some of the other ones that we've seen and how it evolved. And it's certainly on the table. I know there's research being done about what the influence of Hunga Tonga had on that El Nino event when it erupted about a year and a half earlier before that El Nino, actually came on. So some really interesting stuff there. But those are the ones that I'm going to focus on right now. So, and this is simply predicated on the La Nina to El Nino transition. So let's look at those temperature and precipitation analogs. I got them listed up here. This is what happened in March. Average all those out with the temperature anomalies. Still the opportunity for some late season cold to come down here from the north. Just kind of like what the Euro was showing a little bit right there. And I'm not sharing the Canadian seasonal model with you today, but it has this similar look with those temperature anomalies. Precipitation anomalies, you were drier because we were still dealing with kind of a La Nina-like pattern, even Florida, okay, which is oftentimes so dry during La Nina. But we still lacked that subtropical jet stream here in those March. And again, if you look at the scale down here, this isn't terrible, but it is drier historically with the March when we're dealing with the transition. And I've talked at length about that, and the model shows that trend too. So it should be as no surprise that you are wetter the farther east you go. What about April, temperature-wise? Again, still on the table for some late season cold to come down here. Most of the country ended up being cooler than average, all right? But it was especially cooler than average here across parts of the plains in the Midwest and up here in the Northern Rockies. Precipitation-wise, again, you got wet down here across Texas, wetter in the Southeast. We were sprinkling some dryness here from the Western High Plains through the Corn Belt, all right, and right here across Southeast Kansas into Missouri, and also through this sector, all right. But Texas got wet. We started to bring more systems in from the Southwest during April. What about May? Temperature anomalies, historically, we are a lot warmer on the northern tier, and because we've been active farther south, and we're putting water in the ground, look at the cool anomalies here from Southeast California, Arizona, New Mexico, most of Texas, and across the Southeast. What about the precipitation anomalies? This is where I differ a little bit from the modeling, all right, especially for the month of May, because historically, May gets active really in these areas. And I'm just going to highlight them a little bit. All right. But these areas here, right here in the central and western high plains. Now, historically, there's a pretty sharp gradient of wetter west across Nebraska, Kansas, and Oklahoma and Texas, and drier east. You can see that right here. Now, despite the fact that the European model didn't show the sustained dryness here across parts of the Mississippi Valley, the Corn Belt, and the upper Midwest, and the overly wet stuff here, we've seen this set up before. All right. And in some cases, what you will get is high pressure up here, and you do something like this. You funnel dry air down through this quadrant, and that ends up being drier. Meanwhile, moisture from the Gulf of America flows farther west, and that's what lights this area up. That's why you're seeing those wet anomalies right there. So I'm leaning a little bit more towards this solution versus the model at this point, because there's some years here that really back that up. What about June? The Junes have oftentimes been colder than average here across the West, the Southwest, and really across a good part of the country. But what this indicates to me is that we are bringing disturbances out of the Southwest like this, and that is acting on that Gulf of Mexico moisture that returns here to the middle part of the country. Because when you look at the temperature anomalies right there and all that cool, and then you look at what the precipitation anomalies were, you see why. Look how much wetter things were from the Intermountain West spilling out here in the Western High Plains. All right. Kansas, Eastern Colorado, really wet. And you see how the wet signal here eroded that dry signal. It kind of split, didn't it? Where it's more prevalent up here and also down here across a good part of Texas. That's why I was saying with Texas, your wetter part of the warm season might be early, at least in the eastern 2/3 of Texas, and then you start to dry out in summer versus areas out west might be dry early and then kick in. Okay. But you can kind of see that maybe unfolding right here. What about July? July, again, cooler for a lot of areas here because we're shoving water in the ground for a lot of these areas, especially through here. Now, farther south, we start to heat up. That's typically the case when we turn the page to El Nino. And if we turn it more quickly, if say we lopped off a couple of these years where it took a longer period of time to achieve that El Nino status, I think that you would see even a more impressive heat signal the farther south you go, because 2023 was awful across Arizona, New Mexico, Texas, southern Oklahoma. That summer was hot. It was dry after we saw that early season moisture. But we lump them all together here. Those are the temperature anomalies you get. And precipitation anomalies. And again, if you look at the scale down here, we're not really deviating too far from average, but there are some areas here that were noticeably wetter. All right. These areas here, but you were noticeably drier down here. Remember how the European model didn't show a big buster monsoon. It was actually drier. Texas was dry, averaging out these years in July. And we also had some dryness here across parts of the Corn Belt. Again, not a huge deviation from, one way or another from average, but there was some dryness right there. That showed up in these analogs. What about August? August temperature anomalies, again, cooler than average for a large part of the country. Still a little warmth down here farther south. But if we look at the precipitation anomalies, you see where we were drier. We were dry here across, the eastern half of Texas, down along the Gulf Coast, and up through the Mid-Atlantic. And we were wetter across parts of the Corn Belt, back here through the plains. And also, the monsoon got its act together, and we brought some better moisture flow back here across the Intermountain West and up into the Northern Rockies and the Northern Plains. All right. And that is consistent regarding the Corn Belt. That is consistent where the July wasn't really that great in terms of moisture, but we didn't get terribly hot. And then we had better rains in August that helped really finish things off as far as that crop was concerned. I would be a lot more concerned if we were seeing back to back to back months where that area was dry. That would probably help facilitate a wreck. Okay. And into September's, we had some early season chill coming down like this. We had late season warmth still holding on through here. When you do battle with these air masses, with the seasonal change arriving, you get active weather really, okay, anywhere through this sector here, anywhere through there, wetter than average. And the farther southwest you go, there was a little bit of a tail off here in the monsoon out here to the west. So that's why I have some question marks about what this monsoon could mean, based on some of the model information, but also the history. Because when I looked at the Canadian seasonal model a few days ago, it has gangbusters monsoon going on. But the Euro chopped it back from what it did last month. And some of the analog data shows that some of the monsoon season may not be as wet as we would like it. Okay, folks, that's what I have to share with you today. If you have any questions, comments, please feel free to comment here on my YouTube channel. But if there is anything that I can do for you on the daily in terms of your business, regarding forecast information, both day-to-day stuff or seasonal, I do this stuff for a lot of folks, whether it's individuals or insurance companies, whatever. It's what I do. It's really what I'm passionate about, especially in the ag sector. So if this is the first time consuming this information for you, let me know what you think. I never pretend to be the smartest one in the room with this stuff. There are others that are much smarter than I am, but my niche is really trying to take this material and make it be useful and actionable, especially in the agricultural community. And I think there's a lot to glean from pairing the model data up with what history looks like and then going forward with that type of information. Needless to say, it is going to be a very interesting year as we make this transition away from the La Nina toward El Nino during the seasonal change, because a lot of times that helps to facilitate some really active weather in the middle part of the country during the spring months. So again, please let me know what you think. Feel free to comment. That's all I have for you today on this episode of the Desert Farmer Podcast. As I said off the top, I greatly appreciate your loyal listenership, and I'll be chatting with you again real soon. Have yourself a great weekend, everybody.